Alright guys, this video is on the Unit 6 review of AP Calc AB. Remember, this is not for BC because BC has some extra topics like partial fraction decomposition and improper integral, etc. So this is perfect for AB guys. And also this is Unit 6 per the AP curriculum as in from the College Board. I know some schools Unit 6 might be a little different from this, so make sure you check the topics that are in the official College Board description. For example, MVT of integrals will not be here. That is in Unit 7 in the College Board, so you will not find it in this video. All right, as always, you can download the worksheet from the link in the description. And if you need private tutoring, feel free to reach out. All right, the first question is, looks like this is on integral as accumulation. This is very popular in AP, especially in FRQ, definitely usually the first or second question, whether that's AB or BC, is on this topic. Okay, fx is a function consisting of a line segment and a circle, g be a function that is given by g prime as fx, so they're asking that if g of -2 is 0, then what is the value of g of 2? So the way we do this is we integrate because I need to figure out the value of g and I'm given g prime. So the only way we can do this is, of course, by integrating it, right, on both the sides. So, and the bounds of integral should be from -2 to 2 because these are the two numbers I'm interested in. So g prime of x is equal to fx. I'm going to integrate both the sides. So there's a dx here, and the bounds are from -2 to 2. I think we already agreed on that. The integration of g prime is just g. I'm just going to continue over here so that we can see the graph. So this will be gx, and remember the bounds are from -2 to 2. Now, how will you integrate fx from -2 to 2? Area under the curve, right? And remember sine sensitive area. So from -2 to 0, that's just a triangle. The area of the triangle will be half times base, which is 2, and the height, which is also 2. But make sure to put a negative sign out in the front because this is below the x-axis. And the remaining guy is the semicircle. The radius is obviously 1 unit, so it will be pi r square divided by 2, because divided by 2, why? Because that's a semicircle. The left side will become g of upper bound minus g of lower bound. This will become boom boom, -2 plus pi over 2, I believe. G of 2 is what we need to find. G of -2 is, wow, 0 is equal to, let me write pi over 2 first. So pi, or let's keep it like that, -2 plus pi over 2. So isn't that the answer? G of 2 should be equal to -2 plus pi over 2, which looks like option, what do you call it, B, right? Makes sense? All right. This one is, I think, a pretty straightforward question. Here we have to integrate fx, but it is given that fx is same as g prime x. So first I'm going to replace f with g prime. So g prime x dx from 1 to 3. And what is the integral of g prime? I mean, obviously, integral of any derivative is just that function because the integration and differentiation are two opposite operations that, sort of nullify each other. But of course, the bounds remain as it is. So it will be gx from 1 to 3, which is nothing but g of 3 minus g of 1. Well, fortunately, we are given what is g of 3 and what is g of 1 over here. So I'm just going to plug that in right here. G of 3 is going to be, I think, 3 square minus 3 times 3 plus 4. I hope you understand. I'm just replacing x by 3 here. And then every x by 1. So it's just 1 minus 3 plus 4. So it's going to be 9 minus, sorry, not 6, 9 plus 4 minus, this will become -2 plus 4. These are gone. So I'm left with 4 minus 2 is 2. 4 minus 2 is 2 here. And 4 minus 2 once again is just 2. So 2 is, yes, we have an option, which is option C. All right, great. The next one is on, okay, we are integrating a square root over here. I can definitely use a u-sub and do this for you, but I think it would be helpful for you to understand the shortcut that we can apply. Because isn't that almost like a parent function? A parent function as in how will you, how, had there was no 3x plus 1 here, first off, let's bring it to the top, right? So this will be 3x plus 1 raised to negative 1 over 2 times dx from 0 to 5. What I'm trying to say is, if this was just x raised to negative 1 over 2, then you don't really need any u sub. You know that you can use a power rule, add the power by 1 and divide by the same thing. Likewise, you can do the same thing over here. The why? Because this x is just replaced by another linear function. After all, this is a straight line, right? Mx plus b. The, the only difference is, after you find your answer, just divide it by the coefficient of x. Think about it like that. Had I was differentiating this 3x differentiation will be 3, so 3 will come out. So integral is exactly opposite. You have to divide by 3, right? So I'm just going to do it quickly like that, and then I can show you u sub as well. I don't know if some of you are still confused about this. So you add the power by 1, negative 1 over 2 plus 1 is 1 over 2, and you divide by 1 over 2, and then divide by a 3 as well. So the integral will look like 2 over 3, 3x plus 1 raised to 1 over 2, and then you put the bounds from 0 to 5. Of course, if you are not okay with that, I'm going to use a u sub. So u is equal to 3x plus 1, which means that du will be equal to 3 times dx. And remember, the bounds are going to change. So when x is 0, u will be 1. And when x is 5, then u will be 16. So this is going to be 1 to 16, 1 over square root of u. And dx is just from here, if you understand, it's du over 3, right? Because I divide both sides by 3. So this is du over 3. You see that? Over 3, that's what we got from the shortcut. So I'm going to take that 1 over 3 out, and this will be u to the negative 1 over 2 du integration from 1 to 16 over here. So this will become u to the 1 over 2 over 1 over 2 when we integrate from 1 to 16. Over 1 over 2, the 2 is going to jump up using keep change flip. So it will look like 1 over 3 times 2 root u from 1 to 16. So this will become 2 over 3 root 16 minus square root of 1. Square root of 16 is 4. 4 minus 1 is 3. 3 and 3 is gone. So I'm just left with 2 over here. So that should be our final answer. Is that in the options? Yes, we do have that in the options, which is option D. So now you know both the methods. Of course, I prefer the red one. It's fast, saves time. But if you're still confused, of course, you have the blue one. Okay. What is the sum of all values of k that satisfy this? So yes, integration rules here, power rule, I think, but with some algebra also doodling around. So what is the integral of this x? Isn't that just x square over 2? Or maybe I want to rewrite this because I don't like this x square at the bottom. So this can be written as x to the negative 2 dx, and this can be integrated from 1 to 2k, and that should give me 15. Integration of x is x square over 2, and integration of x to the minus 1 is x to the minus 1 over minus 1 from 1 to 2k, and this is 15, or this should give me 15. So this will be x square over 2, double negative is positive, and x at the bottom, and this is going from 1 to 2k, and that should be equal to 15. So if I put the upper bound, this will be 2k whole square over 2 plus k over 2k. That's how the upper bound looks like. And the lower bound will be 1 over 2 because 1 square is 1, and k over 1. So there is no need to write k over 1. I mean, I can write it, but you understand there is no need to write over 1. Okay, this will become 4k square over 2, and this will just become 1 over 2 because k is gone. If I distribute negative, that's how it looks like, and this is equal to 15. Okay, these two are gone. 4k square over 2 is 2k square. So 2k square minus k minus 15 is equal to 0. I think this can be factored minus 6k plus 5k, if I'm not wrong. Minus 15 is equal to 0. This is 2k, k minus 3 plus 5, k minus 3. Great. So I'm not explaining this. I hope you understand. It's just algebra 2 stuff. So I have two values of k. One is negative 5 over 2 and one is 3. They are interested in what will we get if we add these two numbers. So 3 negative 5 over 2 plus 3 is nothing but negative 5 plus 6 divided by 2 if we take the common denominator, which is just 1 over 2. Yes, we do have that in the options. So option B, 1 over 2 is the correct choice. Right. Okay, this is important, guys, because this is the integration of absolute value. And the way we do this is using graphs, because otherwise this becomes slightly complicated if you do not want to use the graph. So this is a classic question of integration as an accumulation. Uh, the way I hope you know the absolute value of x curve is just a v curve at the v at the origin, like this. And the only difference is whenever you have some other stuff instead of x, just find that where exactly is this thing 0 to find the corner point. Obviously, if you want to make x plus 1 0, x should be negative 1, which means that the graph is making a corner at negative 1 like this, and it is going to look like this, right? It's going to look like this. Now, they want us to integrate from negative 2 to 5. So negative 2 is somewhere here, and 5 is probably, I don't know, somewhere over here. We know that integration is the area under the curve. So all we have to do is find what is the y coordinate at negative 2. It's pretty easy. I'll just put x as negative 2 over here. So absolute value of x plus 1 when x is negative 2, I will get absolute value of negative 1, which is 1. So this is going to return me negative 2 comma 1 as the height. And at 5, I'm going to get absolute value of 5 plus 1, which is 6. So 6 is probably somewhere here. Okay, area of the curve is just what? Area of this guy and the other guy. So of this guy, the area is, both are triangles, of course. So the area formula is pretty straightforward. So for the left piece, the area is going to be half base. Base is 1 unit, and height is also 1 unit. So it's just 1/2 A1, and A2 is going to be half base. Be careful, this is 6 units, and height is 6 units as well. So this is, I think, 18, right? Yeah. So the total area is 18 plus, well, half is 0.5, so 18.5. Yeah, makes sense. Should be 18.5, which is option C. Okay. What is F prime? Okay, very important question, guys. This is on FTC 1. Very important. Definitely expect a couple of MCQs, maybe some part in FRQ as well in your AP Calc exam. The way this works is f prime x will be f of upper bound. F of upper bound means just notice what the function is and replace its variable with the upper bound, right? So the upper bound is just x square. So replace every t, well, we just have t at one position over here, with x square. Then multiply it by the derivative of the top. Derivative of the top is x square, derivative is 2x. Minus, put the, although I don't need to write that, if you know this, that's going to just become 0, but I'll still show it to you for those who don't remember. Minus, you put the lower bound again instead of the t variable in this case, so it will become 1 plus 3, times you differentiate the bottom variable. So bottom one is not even a variable, right? The bottom guy, derivative of 1 is just 0 because that's a constant, and that's why this latter half is just 0. So the answer is 2x multiplied by square root of x square plus 3. It's straightforward, yes, but very important. This is extremely important. So in our case, the answer is, yeah, option C, right? Option C makes perfect sense. Okay. Um, this is based on, we have to find what is the integral of that if this integral is k. This is based on u sub. It's a pretty decent question because this x cube is, see, why I know this is u sub is because I need something like the bottom one so that I can use this in the first place. That's how I can convert the answers in terms of k, right? And the bottom one is in terms of a single variable, which is t. Now, it doesn't really matter whether that's t or u or anything. It should be a single variable, not really single variable with a single power, not really x cube or something. So I noticed that if I take x cube as u, its derivative will have an x square. And yes, I have x square outside as well. That can, so the u sub can help me. That's why I thought it's a u sub. So I'm going to take u as x cube, which makes du as 3x squared dx. And this is perfect because 3x squared dx is sitting right here. But mind it, there will be some, what do you call it as, bound changes as well. The lower bound x equal to 0 will be same, but the upper bound x equal to 2 will become 2 cube, which is 8. So this question turns into 0 to 8, and f of x cube is just f of u because x cube is u, and the remaining thing is du. And isn't this same as this? Because again, it doesn't really matter what the variable is, whether variable is u or t or anything, this integral will still be same. So since these two are same, variable is irrelevant, the answer is still k, which is option D. All right. Once again, I think you notice that this is a clear case of FTC1 because it is integrated in terms of a variable and the bounds are some other variable. So f prime x is f of upper bound. So every t is replaced by 2x. Let's do that. Multiplied by the derivative of 2x, which is 2, minus is just 0. I hope you understand now. Same as the earlier question. So since this is a constant, it comes out to be 0. This will be square root of 4x square minus 2x times 2. They need the f prime at 2. So I will just replace x by 2. So this will be square root of 2 squared is 4. 4 times 4 is 16. And 2 times 2 is 4 times 2. This will become square root of 12 times 2, or 2 times square root of 12, and I don't even need to simplify this further because I can see one option that is exactly same as what I got. So this should be our answer, option E. All right, excellent. This one says that there is a graph of fx that consists of 4 lines. Okay, you can see that. And G is this. So use this graph to find the parts A to A. What is G0? Okay, so I think G0 is just you replace x by 0 over here. So let's find out. G0 will be equal to negative 4 to 0 ft dt. And negative 4 to 0 of a function whose graph is given is just the area under the curve from negative 4 to 0. So negative 4 is here, 0 is here. Let's find the area under the curve. I think these are just two triangles the way I see it. What is the area of this triangle? It is going to be half. Let's write it on another line. Half. Base is 3 units and the height is 2 units. And be careful, the other area will be minus because it is below the x-axis. Half, base is 1 and height is 2. So 2, 2 gone, 2, 2 gone, and 3 minus 1 is 2. So this answer is just 2. So it should be third option over here. Sorry, why will I mark 3? Should be option 2, right? Yeah, option 2. That should be our answer. What is the equation of the tangent line to G when x is 3? Oh, that's interesting. So for that, I need to find two things. One is the point, one is the slope, right? Let's find the point first. So for the y coordinate, I need to find G3. So G3 would mean that you replace this x by 3 over here, which was earlier replaced by 0. So negative 4 to 3 of ft dt. No need to find that negative 4 to 0 because you already have that area. So you can break it down like negative 4 to 0 and then from 0 to 3 of ft dt. So this is already 2. The first thing is already 2 as we found in question number A. So this is 2. And 0 to 3 is right here, 0 to 3. So it looks like one rectangle or a square and one triangle. So for this square, the area will be obviously 2 times 2 is 4, but keep in mind it is minus 4. And this will be half times base is 1 and height is 2. So it will be minus 1, minus 4, minus 1, which is minus 5 over here. So this is minus 5 and 2 minus 5 is negative 3. But this is just the point, guys, remember. So the point is 3 comma negative 3. Now for slope, I need to differentiate g, right? So again, we have to use the FTC1. So g prime x will be equal to f of upper bound, derivative of upper bound, so derivative of x is 1, minus 0 because this is a constant, so there is no need to write that. I'm looking for g prime 3, so g prime 3 is f3, which is, well, 0. Well, that's interesting because this is the graph of fx and f3 is 0. So, well, that makes things easy. So my answer will be y minus y1 equal to 0 times x minus 3. So y plus 3 is equal to 0. So y is equal to negative 3. Yes, which is in the options. So it should be the last one. And finally, which of the following statements is false for g? G has a relative minima, maxima, decreasing, increasing, and all that. Okay. For this one, we need to first find g prime x, which we already have. Earlier, we found that g prime x should be same as fx. So for relative maxima or minima, obviously we have to make sure that g prime is either 0 or undefined at these points. So let's find let's find what is f of negative 1, what is f of 3, and what is f of negative 2, because these should be what do you call it as? So these should all give me 0 or undefined, right? So negative 1 is yes, giving me 0. F of negative 1 is 0. F of 3 is also 0. But f of negative 2 is not really giving me 0 in the first place, right? So g prime negative 2 is g prime negative 2 is f of negative 2, which is not 0. So if it is not 0, how can it be a relative extrema in the first place? So they are asking what is false. No need to check the other options. It should be option 3. This should be the false option. All right. Use this graph to answer the following. So we have to find what is f of minus 2. It's sort of similar to the previous question, maybe a little bit more funky. So f of minus 2 is just replacing every x with minus 2. So minus 2 square plus negative 2 to negative 2 of gt dt. Negative 2 square is 4, and I think we know this from the properties of definite integral, that if the lower bound and upper bounds are same, the answer is 0, because basically you're not, tracing any area. So it's 4, and which should be, yeah, we do have that in the option, so that's our answer. F prime negative 2. Okay, what is f prime? So from here, I'm going to find f prime, which is 2x. And I hope you know this. This is now FTC1, so that's just g of x. They're asking f prime negative 2. So f prime negative 2 is f prime of negative 2 is 2 times negative 2 plus g of negative 2. And this is negative 4 plus, what is g of negative 2? This graph is of g, so at negative 2 it is, there you go. At negative 2 the value is negative 2. So negative 4 minus 2 is negative 6, and yes, indeed, we do have that in the options, so it should be option 1. And f double prime f double prime 2, not negative 2, f double prime 2. So we'll just borrow this guy, f prime, from here and ram this once again. So differentiate it. F double prime x will be 2x is 2 and gx will be g prime x. They are looking for f double prime 2, which is 2 plus g prime 2. And what is g prime 2 if you look at it carefully? This is g, and obviously derivative is the slope at that point, which is a horizontal tangent line. So the slope is just 0. So it is 2 plus 0, which is just 2. Do we have that in the options? Yes, we do. So that should be option 4. Okay. If this is this, what is f prime? Once again, another question on FTC1. I hope you know how to do these things now. So f prime x will be, I'm happy that denominator is, sorry, not denominator, the lower bound is once again a constant. So it's, the second half is just 0. So it'll be 1 plus sine x square times derivative of sine is cosine of x minus 0. And that's about it. I'll just write cosine x first. And this is square root of 1 plus sine square x, which, yeah, option D. Right, option D makes sense. Okay. What is the value of g of 2? Okay. This is, in a way, I picked this question because sometimes you don't recognize that this is also FTC1. Because d over dx is, after all, finding the derivative of that thing, right? So this is the FTC once again, FTC1. So gx will be equal to 3 plus, you replace the upper bound, sorry, the variable with the upper bound. So variable is t square, t is replaced by x square. So remember, x square square. I hope you understand what I did here. Again, I'm repeating, I replace this t with x square, and the square of the question is as it is. But we are not done yet. Times derivative of x square, which is 2x, and that's it, because we subtract 0 from here because the denominator is a constant. So g is simplified as 3 plus 2x times 1 plus x to the 4, and I just replace x by 2. So g of 2 will be 3 plus 2 times 2, 1 plus 2 to the 4. This will be 3 plus 4 times 1 plus 16. 68, I think, 70, 71. So that should be our answer, yes, which is option E. That should be it, yeah. Right. Over here, we have to integrate this and figure out what the value of k is. Although we did a similar question, something similar to this. So the integration of 2x is, the 2 is just 2, and x is x squared over 2. Integration of k is just, kx. I hope you understand, because k is a constant. So just like integration of 1 is x plus c, likewise integration of k is this, k just remains as it is. It's kx plus c. So this is from 2 to 6, right? And this should be equal to 8. This 2 is gone. Upper bound 6 square is 36 plus 6k, minus with the lower bound 2 square is 4 plus 2k. That should be equal to 8. So 36 plus 6k minus 4 minus 2k is equal to 8. 36 minus 4 is 32. 6k minus 2k is 4k is equal to 8. Subtract both sides by 32. So I think that's what, negative 24. And divide by 4. 4 times negative 6 is negative 24. So yeah, negative 6, option A. Guys, that's what I'm getting. Option A should be our correct choice. Okay. This is a pretty interesting question. No, you do not have to integrate this entire gross thing, because notice carefully, if you remember the even odd functions property, all these with odd powers are odd functions. And when odd functions are integrated from negative a to a, to remind the memories, negative a to a fx dx is, if fx is an odd function, is just 0. So these two are just gone because they are just, 0. You're just left with negative 4. So this question is essentially integrate negative 4 from negative 8 to 8. So negative 4 comes out, it's a constant, integrate from negative 8 to 8 of dx, and integration of dx is basically, 1 dx, and integration of 1 is just x from -8 to 8. So it will be -4 times upper bound minus lower bound. So it will be -4 times 16, which is -64. So option C is the best choice. Okay, over here we need to figure out, although this is a similar question as to what we did, but there's a reason why I picked this one. We need to find g of -1. So g of -1 will be from 0 to -1. And now you see the weirdness here. The lower bound is higher than the upper bound, right? So usually students mess these up with a sign. So we should understand that in order to write this in the usual notation, you swap the bounds, -1 to 0 ft dt, and you put an extra negative sign out in the front. And now it becomes a regular question. -1 to 0 ft dt is what? -1 to 0 is basically the area under the curve of this portion, right? So that's just negative remains as it is. And since this area is below the x-axis, another negative, half times base times height. So the answer is 1 over 2 and not -1 over 2. Well, that's the only thing, only probably catch here that we have to, take care into account. So that should be our answer. And the others should be straightforward because they are asking g prime now. So g prime, I think you very well know, g prime of x will just be f of x. So they are asking g prime of -1, sorry, -1 is just f of -1, and f of -1 is just -1, right? F of -1 is just -1. So this is -1 right over here. Okay. And then I have g double prime -1. So g double prime is just, I differentiate this once again. So g double prime x will be equal to f prime x. So g double prime -1 is just f prime -1. And f prime -1 is, what is the derivative of this function at this point? Well, derivative is just the slope. And we can see that this is the slope of this line is rise over run. There is a rise of, there is a rise of 2 units and there is a run of 2 units. 2 over 2 is just 1. So that's just 1. That's our answer. Right. Here we are given if gx is the integration of secant tangent and g of pi over 4 is this, then what is g of pi over 3? Coming on to trig rules here, guys, I hope you remember what is the integration of secant tan. If you do not, then it is secant. You can think about it in the other way, that when you differentiate secant, you get secant times tangent. So if you reverse engineer, you will end up with secant. So gx is secant x, not just that, plus c, because this is not a definite integral. And that's why they gave this piece of information so we can figure out what c is. So I'm going to put g of pi over 4, which is secant of pi over 4 plus c. G of pi over 4 is -4. Secant pi over 4 is root 2 plus c. So -4 minus root 2 is c. This I'm going to sub in over here. So I'm going to get my gx as secant x plus, not plus, c is -4 minus root 2. They're asking what g of pi over 3 is. So that will be secant of pi over 3 -4 minus root 2. Secant of pi over 3, what is cos of pi over 3? Pi over 3 is 60 degrees. Cos 60 is 1 over 2. So secant 60 degrees is 2. So 2 minus 4 minus root 2 and 2 minus 4 is -2. So it will be -2 minus root 2. That should be our answer, which is option C. That adds up. All right. Okay, integral. No one likes this thing, but yes, we have one question so that you can, this will rejig your memories. Right, so the way this works is, this is a Riemann sum, and the way we convert a Riemann sum into a definite integral is, the general structure is limit n approaching infinity, summation of i's from 1 to n, f of a plus delta x multiplied by I times delta x. That's how it looks over here. One parentheses is missing, guys. There should be a big parentheses over here so that there's no confusion. Okay, this should be the complete question. Where delta x is given by b minus a over n. Obviously, what is b, what is a, you will come to know, because this is equal to a to b fx dx. That's how it works. So the best way to answer this question is to reverse engineer. We can see what b and a are. So b minus a over n, that should be the delta x, which should be sitting right outside, which is over here. In other words, b minus a should be 6. So what is 11 minus 5? 6. 6 minus 5, 1. 11 minus 6, 5. 6 minus 0, 6. So that only eliminates, this thing only eliminates b and c. Now, look at the function. What will make sense? Now, what is a? The question is a 0 or is a 5? I think 5 makes sense because look at the inside. It should be a plus delta x times I. And this is a plus delta x, a plus delta x. And this is just a constant. So constant doesn't have any x to replace. So obviously the lower bound should be 5. So that should be our answer. Okay. Okay, evaluate this integral. So usually this is easy, but it still trips students up. All we have to do is distribute that. In other words, give this denominator to all these people separately so that we can apply the power rule here. In other words, write it like this. 6x cubed over x squared minus x over x squared dx, and you integrate and then reduce the power. So this is 3x squared minus 6x minus 1 over x dx, and then just apply the rules here. 3 is as it is, x squared is x cubed over 3. 6 is as it is, x squared over 2, and 1 over x is ln absolute value of x. Don't forget plus c. So the answer will be x cubed, 3 and 3 is gone. 6 over 2 is 3, 3x squared minus ln absolute value x plus c, which looks like option D. No, minus, yeah, option C. That should be our correct choice. Okay, pretty good question. This is a u sub because there's no power rule or anything here. And whenever I see ln x, most likely it has to be some other integration techniques. And in AP, there are not many integration techniques. So this is a u sub because I can see 1 over x sitting here, which is basically the derivative of ln. So I'm going to take u as ln x. So du is going to be 1 over x dx. And if we rewrite this as 1 over x times 1 over ln x dx. So you see this 1 over x dx, that's just a du, and you see this ln x, which is 1 over u. So 1 over u integration is ln absolute value of u plus c. And what is u? That's just ln x. So it's ln of absolute value ln x plus c, which has to be option B over here. That's the answer. Okay. Evaluate this. So what is the integration of cot? Well, that is the only question. Cot is negative. Sorry. Okay. I was about to write negative cosecant square x, but that's not right because that is the derivative of cot, not the integration. So the integration of cot is ln of absolute value of sine x. So unfortunately, guys, you have to memorize these things from pi over 6 to pi over 4. So it will be ln of absolute value of sine of pi over 4 minus ln of absolute value of sine of pi over 6. Sine of pi over 4 is root 2 over 2, and sine of pi over 6 is 1 over 2. So this can be ln a minus ln b is ln a over b. I hope you remember the properties. So ln a over b. I'm going to use keep, change, flip. So keep, change, and 1 over 2 is flipped. 2 is gone. So I'm left with ln root 2. and that should be our answer, which has to be option A. All right. If f prime is this and f0 is ln 21, then what is fx? So this is sort of like a differential equation, not exactly, there's a separate unit for it. But in a way, f prime x is given as 1 over x plus 3. And to go from f prime to f, I need to find the antiderivative of it. So I integrate both the sides here. So f prime x dx integration will be equal to 1 over x plus 3 dx integration. Integration of f prime x is fx. 1 over x plus 3, obviously you understand this is the same as 1 over x parent. So what, ln, right? Ln x plus 3, absolute value of x plus 3 plus c. I'm given an initial value to find c. So replacing x by 0. So f0 is equal to ln of absolute value of 3 plus c. f0 is ln 21. So ln 21 is equal to ln 3 plus c. So ln 21 minus ln 3 is c, and ln a minus ln b is ln a over b. So ln of a over b is c, which means that c is ln 7. 3 7s are 21. Let's plug that back in over here. So our function becomes ln absolute value of x plus 3 plus ln 7, I think, right? So that should be our answer, which I don't see anywhere in the options, but yes, they're actually playing with us because they have again used a log property, because log a plus log b is log of a times b. And a positive number can very easily go inside an absolute value. So it will be ln of absolute value of 7x distributed. So it will be 7x plus 21. That should be the function, which, yes, it is option A. Okay. Evaluate this. So this again looks like a u sub in this case, although this is a definite integral, but it doesn't really change the approach. So u is going to be ln x. So du will be 1 over x dx. So this 1 over x dx I can just see over here. This is replaced by du. Ln x will be u. But be careful, the bounds will no longer be the same because this is a u sub. I'm going to replace x by 1 because that's the lower bound. So u will be ln 1, ln 1. And what is ln 1? 0. And then x is e. So u will be ln e. And what is ln e? That's just 1. So now over here, I think I will have integration of u du from, what was that? I think 0 to 1, right? 0 to 1. So integration of u is u square over 2 from 0 to 1. Upper bound is 1 square, which is 1, and over 2 remains as it is, and minus the lower bound is 0. So the answer is just 1 over 2. Yes, 1 over 2 is in the option, so it should be option C. Okay. The next one is evaluate x tan of x squared dx. So of course, had this was just tan x, I do have a formula, but these are some funky stuff going on here. Classic u sub, where u is going to be x squared. So if I find du, it will be 2x dx. And I do see x dx in the question. So I'm just going to divide both sides by 2. So that it will be half du is x dx. So if I rewrite this question, let's write tan of x squared first and then x dx. The reason is so that you can easily see this x dx is now replaced with half du. So half du. And x squared is anyway u, so tan of u. 1 over 2 is thrown outside, so 1 over 2 integration of tan of u du. And the integration of tan is negative natural log of absolute value of cosine x. That's just a formula, guys. You have to memorize these formulas, plus c over here. So the final answer will be negative 1/2 ln of, sorry, this will no longer be, made a mistake here, x, this will be u because that is in the u world. And in the final step, negative 1/2 ln absolute value of cos of u will be replaced by x squared. So it will be x square over here and plus c. So that should be our final answer. There are no options here, but yeah, this is our answer. Okay, all right. We have to integrate sine of 4x dx. So again, the integration of sine is minus cos, of course. So minus of cos of 4x. But since there is a 4 over here as the coefficient of x, you have to nullify that effect by dividing by 4, on the outside. If you again do not understand this, just like the earlier question, I think in the first 5 questions, I used a u sub. You can do that, but honestly, that's a bit of an overkill. You should be used to applying such shortcuts over here. And the bounds are from pi over 4 to negative pi over 2. Negative 1 over 4 sits outside, and I put the upper bound, which is minus pi over 2. So it's 4 times minus pi over 2 minus cos of lower bound, which is 4 times pi over 4. So this is negative 1 over 4 cos of negative 2 pi minus cos of pi. Cos of negative 2 pi, remember cos is an even function, so it has nothing to do with, even if the negative sign is sitting outside, just digests it. So it's cos 2 pi minus cos pi. Cos 2 pi is 1 and cos pi is minus 1. No calculators allowed. I hope you remember your unit circle stuff. So this will be negative 1 over 4, 1 plus 1, which is going to be 2 over 4, negative 2 over 4, which is negative 1/2. That should be our final answer. Right, a decent question. Let's try the next one. All right, guys, this is a good question because this is based on something called uh, 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 a u sub, of course. Why is this a good question? Because sometimes it is difficult to see what the u is. So there are two possible u from this question. One is tan, because the derivative of tan is secant square x dx. And one is secant, because derivative of secant is secant x tangent x dx. So you can strip out one secant from here and take that as u, which is totally fine, but I'm not going to do that. I'm just going to do what looks like a straightforward u, which is tan of 2x. So du is going to be derivative of tan as secant square 2x, and derivative of this 2x is 2, so 2 comes outside. Divide both sides by 2, so 1 over 2 du is secant square 2x. Okay, the bounds are definitely going to change. So the initial x is 0, so u will become tan of 0, which is also 0. And the upper bound is pi over 8, so u is tan of 2 times pi over 8. 2 times pi over 8 is pi over 8 is pi over 4. Tan of pi over 4 is 1, so upper bound is 1. So the integration looks like 0 to 1, tan of 2x is u, and secant square 2x dx is, oh, I missed a dx over here. There's a dx here, and yeah, that should be replaced by 1/2 du. So 1/2 du. Okay, just gonna take 1/2 out, so integration of u is what we are left with. Integration of u is u square over 2, which is from 0 to 1. So this will be 1 over 4, upper bound 1, lower bound 0. So the answer is just 1 over 4. That's our final answer for this one. Okay. These are pretty decent questions, guys. These are based on the properties of definite integral. We are given a bunch of information over here, and the first question is, what is the integration from 0 to 4 of 3 times fx dx? First, I think I'm just going to take 3 out. So 3 times integration of 0 to 4 from fx dx. Now, although I do not know what is the integration from 0 to 4, but I know 0 to 2 and 2 to 4. So this can be written as 3 times, I can integrate this from 0 to 2 first, fx dx, and then integrate from 2 to 4 fx dx, which is basically the same thing. So it's going to look like 3 times 0 to 2 integration is just 2, and 2 to 4 integration is 7. And 7 plus 2 is 9. 9 times 3 is 27. So our answer for part A is 27. Okay. Then we have 0 to 1 of fx dx. Once again, I do not have 0 to 1, but what I do have is 0 to 2 and 1 to 2. So obviously it makes sense that 0 to 1 integration is same as you integrate 0 to 2 fx dx, and then you subtract it from 1 to 2 fx dx. So you're going to get from obviously 0 to 1. So that's 2 minus minus 1. Be careful with the double negative. So the answer will be 3. The next is 0 to 1 x dx. Well, I don't really know what this has to do with the... Okay, there is a typo, of course, in the question. This is not x plus 1. This is f of x plus 1. So please make sure you have that correction. Okay, so f of x plus 1, I don't really have f of x plus 1. I have all these people as fx. So fx or gx. So I have to do a u sub, of course, because I do not need x plus 1 here. I just need a single variable. So I'm going to take u as x plus 1. So obviously du is just dx. But remember, the bounds are going to change. When the lower bound is 0, x is 0, u will become 0 plus 1, which is, of course, just 1. And when I have the upper bound as 1, the u will become 2. So the integration will be from 1 to 2 f of u du. And the benefit of doing this is I do have 1 to 2, right? There you go. 1 to 2 fx dx, isn't that minus 1? I mean, I can go back to the question. You can have a look at it. 1 to 2, there you go. Now, I already told you it doesn't really matter whether the variable is x or u or t or z or anything. The idea is the structure is same. So 1 to 2 integration is negative 1. And yes, 1 to 2 integration is indeed negative 1. That's what I have here. So that should be our final answer. And finally, we have this thing. So first I'm going to distribute. So this is going to look like 2 comes out, 0 to 2 integration of fx dx, and 1/5 comes out, 0 to 2 integration of gx dx. Okay, now what is the integration of f from 0 to 2? I think I have this number, 0 to 2, 0, yeah, there you go, 0 to 2, there you go. 0 to 2 is just 2, so there you go, this thing is just 2. Minus 1/5, and I think this number is also given from 0 to 2 of g, there you go. 0 to 2 of g is negative 5, so I'm going to put negative 5 over here. Negative 5, so this will look like 4 plus 1 if you agree, because 1 over 5 and 5 is gone, and minus of minus 1 is plus 1, and 4 plus 1 is just 5, so that should be our final answer. Okay, pretty good question, time taking, but yes, important. This is based on even odd functions over here. So we are given that we have to find what is negative 3 to 3 of f of 3x. Same idea, guys. I do not really know what is the value of, I do not have any information in terms of f of 3x, so I have to do a u sub once again. So if u is 3x, du is going to be 3 times dx, or 1/3 du will be dx. Yes, the bounds are going to change. So the initial bound of u will become at x equal to minus 3. This will become minus 9. And the upper bound will become, that's not right u here. The lower bound will become minus 9. You understand? An upper bound, if I put 3, will just become 9. So the question boils down to negative 9 to 9. F of 3x can be written as now f of u, and dx is 1/3 du. So this will look like 1/3 negative 9 to 9 of f of u du. And remember, f is an even function. So for even function, the idea is negative a to a integration of an even function is 2 times integration from 0 to a. And in this case, of course, our a is 9 of f u du. So this will be 2 over 3, and 0 to 9, bingo, we do have that. Once again, I hope you are not confused because the variable is different. That's irrelevant. The structure matters. So this is just 12. And 3 times 4 is 12 and 4 times 2 is 8. So the answer is 8 over here. Likewise, I'm going to try the other one as well. Same idea, guys, literally. I have to do u as 1 over 3x. So du will be 1 over 3 dx. So 3 du is dx. Bounds will change. When x is negative 3, u will become negative 3 over 3, which is negative 1. And when x is 3, u will become 1. So this is going to look like negative 1 to 1 f of u, and dx will become 3 du. So 3 du. So this will look like 3 times integration from negative 1 to 1 f of u du. And once again, f is an even function, so this can be written as 2 times integration from 0 to 1 of fu du. Unfortunately, I have 0 to 1 integration of fx, which is just 4 over here. So I'm just going to replace that thing by 4. So answer is 3 times 2 times 4, which is 24, right? This is 24, so that should be our final answer. And find finally negative 9 to 9 fx dx is f is odd. Big 0. The answer is big 0 because negative 9 to 9, that's just a formula that if negative a to a of fx dx, if f is odd, the answer is 0. All right. All right, guys, question number 28 is on the trapezoidal Riemann sum and all those guys. So, concert tickets for a Taylor Swift concert went on sale, alight, t equals 0 and was sold out within 7 hours. You can see that for some time we are given the number of people who are waiting in the line and the rate at which the number of people are changing per hour. You have to use a trapezoidal term with three subintervals to estimate this. Okay, so 0 to 4, clearly 3 subintervals will be the first interval is 0 to 2, then 2 to 3, and then 3 to 4 over here. The way trapezoidal sum works is the area of trapezium is half of uh, the L1 or L0 plus L2, that's how we say it, L0 plus L2, because this is the like sum of two parallel lines, times the width, which is just the distance between 0 and 2, which is just obviously 2 units. Likewise, 1 half, next will be L2 plus L3 multiplied by the width, which is, this is 2 units, this is 1 unit, so 1 unit. And then 1 half, once again, L3 plus L4 multiplied by 1 units. So this will be 1 half, L0 is 120, this is 156 multiplied by 2, plus 1 half, this is 156 plus 176, and this is 1 half 176 plus 124 over here. So this comes out as, the calc is active here, by the way, guys, the calc is active. So if I use calculator, I am going to get 592. So that should be our answer over here. Okay, then we have used the right-hand Riemann sum with 4 subintervals to estimate 0 to 7 of L prime t dt and explain what this value means in the context of the problem. So we do have L prime t over here, and this is a right-hand Riemann sum, guys. Right-hand Riemann sum would mean that I will start from 4 subintervals. So the points that I have to take, I start from the right side, and these are the 4 points that I'm looking for. So right-hand Riemann is basically, you know very well that it's area of rectangle, right? So the first width is going to be, the width are already written over here. I'll just add the last width, which is 3 units. So for this one, the first width is 2 units multiplied by f of, sorry, not f of 2, L prime of 2. That's what we are looking for because this is L prime. Then it will be 1 unit times L of L prime of 3. Then we have 1 unit times L prime of 4, and then we have 3 units times L prime of 7. That's how it works. I hope you understand, because we have to take these 4 respective positions for right and Riemann sum. we have all the numbers over here. So I'm just gonna sub in 22 here, 28 over here, negative 32 over here, and negative 16 over here. And if I do all that, I'm gonna get negative 8. So they are interested in explain what this means in the context of the problem. Since we are integrating people per hour in a way using Riemann sum, so we will get people. So negative 8 people would mean that they started with 120 people, right? The line started with 120 people, and at the end of 7 hours, there are 8 less people. So we can say that at t equal to 7 hours, people waiting in line are 120 minus 8, which is 112. 112 people are waiting in the line. That's how it works. And finally, the last one is if L prime is strictly decreasing and concave up in 0 to 3, would a right-hand Riemann over-approximate or under-approximate or overestimate or underestimate this thing? So remember that Riemann has nothing to do with concavity and everything to do with increasing or decreasing. If the function is increasing in nature, then left and Riemann sum is an underestimation, you should know that, and right and Riemann sum will be an overestimation. So since this is an increasing function and we are looking for the right and Riemann sum, this is clearly an overestimation from 0 to 3 of L prime t dt. That's how it works here. Right, integrate the following. So now we are coming to the other integration techniques. For example, this one is inverse. And to be very precise, this is inverse tan. But the only thing is I'm not really comfortable with this. First off, I want to see x term or x square term first. So this is 1 over 9x squared plus 2 dx. Now I'm not comfortable with this 9 because the formula that I have is x squared plus a square kind of. So I'm just going to take this 9 as a factor. So I'm left with x squared plus 2 over 9 dx, and obviously 1 over 9 is thrown outside the integral. And this can now be written as 1 over x squared plus a square. So a square can be square root of 2 over 9 square, right? And the formula that we are looking for is integration of 1 over x squared plus a squared dx is 1 over a tan inverse x over a plus c. That's the formula. So clearly just be careful. There are too many moving pieces here. So 1 over a, and a is this one. A is the square root of 2 over 9. Tan inverse x over a is root of 2 over 9 plus c. That's what we are looking at. Of course, we can simplify this. So 1 over 9, this can be keep change flip, so it will become root of 9 over 2. And once again, this will be keep change flip, so root of 9 over 2x plus c. And what is square root of 9? Isn't that 3? So 3 over square root of 2, tan inverse 3 over square root of 2x plus c. And finally 3 times 3 is 9, so 1 over 3 square root of 2 tan inverse 3x over square root of 2 plus c. That should be our final answer. I hope this one makes sense. Right. The next one that we have here is this one. So this is also a trick, but not as straightforward. Pretty interesting question. First, I'm going to split this up in two integrals. So this denominator root of 4 minus x squared is given to x and written as the first integral, plus 2 over root of 4 minus x squared is written as the second integral. This 2 can be thrown outside, so integration of 2 times integration of 2 square minus x squared dx, and this is just x over square root of 4 minus x squared dx. So this is basically two questions, right? And I'm not sure if you're able to recognize this, but this is a sine inverse x situation. because integration of 1 over square root of a square minus x squared dx is sine inverse x over a plus c. It's not, guys, I have seen some of my students making this mistake that they write 1 over a sine inverse x over a plus c. No, it's not. The 1 over a is with tan inverse and excuse me, and secant inverse, not with sine. So for this one, I do have the integration ready. It's sine inverse x, which is x, over a. Remember that a is obviously 2 in this case because, 4 is written as 2 square and a square, so a is 2, plus, of course, c. The question is how to integrate this one. And that, my dear friends, is u sub. So I'm just going to do that separately over here. X over square. So I'm going to take u as 4 minus x squared. So du will become negative 2x dx. So dividing both sides by negative 2, I have negative 1 over 2 du is x dx. And now if we look at it carefully, x dx is what? Negative 1 half du. And 4 minus x squared is u, so square root of u over here. So it will be negative 1 over 2, 1 over root u can be written as u raised to negative 1 over 2 du, and this will become 2 sine inverse, it's just as it is, I'm just rewriting it. And how do you integrate this one? That's just add 1 to the power, so it will become 1 over 2 and divide by the power, and then everything else is as it is. 2 da, 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 da. This 2 jumps up, so it will become negative 1 over 2 times square root of u plus, oh my god, I'm tired of writing this again and again. Okay, finally these two are gone, and I'm just gonna put the u now. And what was our u? 4 minus x squared, as we can see. So final answer is this plus most important guy, c plus c over here. So that should be our final answer, guys. I hope you understand this question and maybe like this question as well. Pretty decent one. Okay. The next one that we have is this. So this is based on the concept of completing the square. Yes, that is a part of AB. I'm not sure if your teacher has covered it, but yeah, this is a slightly tricky one where you have to convert this guy into a perfect square. So probably your knowledge of SAT is going to help you if you still have it. So the first step of converting, I can obviously do it separately. So first step of converting a quadratic into a perfect square is to make the leading coefficient 1. So that I'm going to make by taking 2 as a factor. So x squared plus 2x plus 2 over here. And then the next step is you locate the coefficient of x, which is 2 in this case, divide 2 by 2, which is 1, and add the square of 1 and subtract the square of 1. So 1 square and minus 1 square. That's a procedure, right? That's a procedure. And once you do that, the first 3 terms are going to convert into the perfect square. So this will be x plus 1 whole square, and obviously minus 1 plus 2 is just plus 1 over here. So now our question becomes 1 over 2 times x plus 1 square plus 1 dx. 2 can be thrown outside, so 1 over 2 integration of 1 over x plus 1 square plus 1 square dx. And what does this look like? Tan inverse, because it's x square plus a square. Even though x is x plus something, that's totally fine. Tan will work. So the answer will be 1 over a, because a in this case is 1, tan inverse x plus 1 over 1 plus c. So that will be 1 over 2 tan inverse x plus 1 plus c. That's our final answer. All right, and finally, we have a question that is based on the long division technique. How do I know this is a long division? Because this is clearly the degree of, both are polynomials on the top and bottom, but the degree of top is more than the bottom. Or even if it is equal, then also it is a long division. Once again, guys, if you don't remember long division, please make sure you review that once. Although I'll also try to explain it as much as I can, but this video is not focused on long division. It should be a part of the prerequisite that you should have. The first thing is, if there are any missing degrees, make sure to place the placeholders in the dividend. So it will be 0x square minus 27x plus 2. And we start dividing it. So x cube divided by x square is just x. So I have x here. And this will be multiply this x with this entire thing. So x cube minus 6x square plus 9x. We subtract, change the sign, gone. This will be 6x square. If we add these two and if we add these two, this will be, I think, what, 36, right? 36, 3, yeah, I think, yes. And 2 is dropped down, and then once again I divide 6x square by x square to get 6 and multiply 6 with these entire thing. So this will become 6x square minus 36x plus 54. Gone, gone, gone. So this and this is also gone. So I'm just left with a remainder of 56. Okay. So the question is actually now dividend over divisor will be equal to the quotient, which is x plus 6, plus remainder, which is 56 over the divisor, which is x square minus 6x plus 9. And this entire thing is supposed to be integrated now. So we are yet to integrate this. And yes, you are right, this also converts into a perfect square scenario. So we have to do that. Obviously, integration of this is pretty straightforward. So let's convert this into a perfect square separately. Actually, you know what? It just feels like, oh, okay, no. Okay, it looked like that, but it's not that bad actually. If you think about it, this is just x minus 3 whole square. Right, it is indeed x minus 3 whole square. So that makes things pretty easy for us, because now this question is nothing but integration of x, then integration of 6, and then integration of 56 times x minus 3 raised to minus 2 dx. That's how it looks like. So this will become integration of x is x square over 2, integration of 6 is 6x, 56 is as it is, and integration of x minus 3 to the minus 2 is x minus 3 to the minus 1 over minus 1 plus c. So our final answer over here will be x square over 2 plus 6x minus 56 over x minus 3 plus c. So that should be our final answer. I hope these questions were helpful for you guys. If you found this video helpful, please like and subscribe. Please share it with your friends. And if you need private tutoring, feel free to reach out. Thank you.